This is the video lesson for oscillatory motion. The learning target for this lesson is, I am learning to examine and describe oscillatory motion and wave propagation in different media. Test criteria for this lesson are, I can examine how objects behave when they oscillate, I can describe the oscillatory motion of different objects, and I can describe how wave propagation changes in different media. So what happens when objects oscillate? So to start with, we call this oscillatory motion. An oscillatory motion can create waves in certain media. So for example, a mass on a spring, pendulum swinging back and forth, a tuning fork, or even speakers. So when we have any of these objects, if we were able to look at a displacement versus time graph of anything, of any of these objects oscillating, we would see something that looks like a sine wave. And these objects oscillate around a central point called the equilibrium point. So we'll actually look at a couple of examples of a spring with a mass on it bobbing up and down, and we'll look at the graph of a motion detector watching this spring oscillate, and then we'll see a pendulum swinging back and forth and see what a motion detector shows the graph look like. So waves propagate differently in different media. So the speed of a wave depends on the media it travels through. So the wavelength changes when a wave enters different media. So depending on the medium, the wave will change speeds. So a sound wave traveling through the air is slower than a sound wave traveling through the water or through a solid medium like a table or through metal. Most types of waves need a medium to travel through. So sound waves, they have to travel through air or through a solid medium like metal or wood, or a liquid medium like water. And other mechanical waves like a wave in a string, for example. Electromagnetic waves, which are light, can travel through a vacuum, but those are the only types of waves that can travel without a medium. In the next several images, we're going to look at different waveforms, and we're going to imagine that the waveforms that we see are passing by in the same amount of time. That's going to be important for figuring out the difference between the wavelengths and the frequency. So for this first wave, let's talk about where the wavelengths are. So if we start here, at this point, here is one wavelength. So you can see we have 1, 2, 3 wavelengths. So there's 3 wavelengths for this wave in this image. It takes the same amount of time for these 3 wavelengths to go past this window as it does for the wavelengths in the next images to go past. So we could say that this is kind of a medium frequency wave. All right. In this image we have, so if we count the number of wavelengths, we start here, we go 1 wavelength, and then we have about a half of another wavelength. So we go up, and we get to this point here, so that is about a half of another wavelength. So we have 1.5 wavelengths, 1.5 wavelengths. So, and this takes as long to go past this one through this window as the previous image went through its window. So the frequency in this image is lower than the last. So 1.5 wavelengths went in the same amount of time as 3 wavelengths went in the last image. So the frequency is lower in this one than the last one. And the wavelengths are longer. Wavelengths are longer in this image than in the last image. So longer wavelengths, lower frequency. All right, and finally, we have this last image. So here we have a lot more wavelengths that's going to pass by in the same amount of time. So let's count the number of wavelengths. So we start here. We have 1 wavelength, 2 wavelengths, 3 wavelengths, 4 wavelengths, 5 wavelengths, 6 wavelengths. So we have 6 wavelengths in this image. So 6 wavelengths pass by in the same amount of time that in the 2 previous images we had 3 wavelengths and then 1.5 wavelengths. So the frequency here is much higher. Frequency is much higher. Because we have all 6 of these wavelengths pass by in the same amount of time that in the previous images we had 3 wavelengths pass by and 1.5 wavelengths pass by. And the wavelengths themselves are shorter. So we start to figure out the relationship between wavelengths and frequencies. So long wavelengths mean low frequencies, and short wavelengths mean high frequencies. All right, everybody, keep asking questions. That's how you learn new things.